So this is the factor theorem. Okay, so once upon a time, we talked about P's and Q's. Remember P's and Q's? P were all the factors of the first term. Q was all the factors of the second term. So all of your rational, okay, what is that word? What does rational mean? What's rational versus irrational? Irrational doesn't stop, doesn't repeat, so rational stops or repeats. Rationals are your cute answers, and fractions are cute. Rationals would be like 5, 7, 1/2, -2/3. Irrational is going to be like 6 plus or minus 2i root 7 all over 5. So anything with a root in it or an I in it is irrational. So P's and Q's give you pretty answers, okay? So use the P over Q method and synthetic division to factor the polynomial and then solve it. Okay, so look at number 1. How many solutions does he have? He has 3. How do you know that? That's his highest power. His highest power always tells you how many solutions he has. Now, these 3 solutions could be real, imaginary, rational, irrational, I don't know. But it wants me to find all of them. Now, it's 4 terms. Like when I see 4 terms, I'm like, I don't need to do this P over Q stuff. I can factor that. All right, so start looking at number 1. If you did grouping with that guy, what would you take out of the first group? An x squared. And what would that leave you with? X plus 4. What could you take out of the second group? A 1. And what would that leave you with? And is that good? No, because your parentheses would not be the same. So grouping is not an option here. Okay, if it is, go grouping. Go factor this sucker. So I can't do grouping. So I need to use my P's over Q's to help me figure out what? What would I do with my P's over Q's? Well, let's do the P's over Q's first so we can see what that part looks like. Write small. Okay, so who's P? The last guy. And I might have said it backwards earlier. Did I say it backwards? P is the last guy. Q is your first guy. I think I did say it backwards. So P are all the possible factors of 6. So what do you got? 1, 2, 3, 6. -1, -2, -3, -6. Y'all remember that? So what do we put at the front? Plus or minus. 1, 2, 3, 6. Over. Now Q is the first guy. So plus or minus 1. So if this guy has any rational solutions, and he's an odd power, so he has to have at least 1, it's going to be 1, 2, 3, 6, or -1, -2, -3, -6. Now, back in the day when we didn't have a graphing calculator, you just start doing what with these numbers to see if they worked. Don't say plug it in. Don't ever say plug it in. Don't just ban that from your math vocabulary forever. What do we do with the 1, 2, 3, 6 and the -1, 2, 3, 6? Blah. Well, when you say plug it in, do you mean like plug them into the original function? Like, what's that going to tell you? It's going to tell you where that function is at that particular x. It's not what I'm interested in. I'm interested in his solutions. Solutions are your roots, your zeros, and your x-intercepts. So if you take a 1 and plug it in there, you're going to get some number. I don't know, like 12-ish? No. 4-ish, maybe? 2-ish? And that's just going to tell you what your y is at 1. Okay, and how do you tell if x minus 1 is a factor? The shelf division. What's that called? Synthetic division? And what would synthetic division do? Like, why? How would that tell us if it's a factor or not? If you get a 0 as a remainder, remember it divides evenly? Like 2 goes into 10, right? 2 is a factor of 10 because it divides evenly with no remainder. 3 is not a factor of 10 because when I divide, it doesn't go evenly. So I need to see which ones of these numbers divide nicely into the mothership. Well, to do that, I'm going to do synthetic. I'm going to put these suckers on the shelf. Well, how many suckers do we have? Technically, you have 8 because you have the positive and the negative. Now, I don't really want to sit here and try 8 different numbers. What do we have access to? We have a calculator. What do I do with that calculator? You can't say that. Graph it. And look for what? Yes, the x-intercepts, because your x-intercepts are your solutions. So, go graph him. What are we thinking? 1, -2, and -3? We're thinking? Okay, now, can you, like, take that to the bank, or do you have to prove it? You have to prove it. So you prove it by putting one of them on the shelf and showing me that you get 0 as a remainder. So which one do you want to try? 1. Okay, we'll try 1. Okay, so put 1 on the shelf. Yes, sir. I'll hit enter. Your plot's on. There you go. Okay, so when I do synthetic division and I have the 1 on the shelf, what goes here? And you have to watch out for what? Holes. Good. Do you have any? No. Hi, Benjamin. 1, 4, 1, -6. Okay, now if we could only remember how to do synthetic division. Drop the 1. Multiply. 1 times 1 is 1. Add. 5. 5. 6. 6. 0. What do I do with him? Shelf him off. Because who is that? My remainder. What did you just prove? That 1 is a solution. X minus 1 is going to be your factor, but 1 is a solution. All right, so I've got one of them. Now, where else do we think it crossed? -2. Okay, now, all right, time out. Don't write. Just watch. Okay, so I could take this line right here and go -2. So 1, -2, 3, -6, 0. And then who is the other one? -3. 1, -3, 0. I got zeros for all the remainders. I just proved that all 3 of them are solutions. Okay, but I could right here with what I have left throw x's back in here and just, I know how to factor this to get the other 2 that way. I'm just showing you have options. Okay? So his solutions are a 1, a -3, and a -2, which I thought from my calculator, but you have to prove it. Now, you can write whichever way you want to go. You want to go synthetic all the way down. You want to go to its quadratic and then go factor it. That's fine too. Either one is fine. Okay, number dos. 4 terms. Can I do grouping? If I can do grouping, I can avoid all of this. Can we do grouping? If we do grouping, do good things happen or bad things happen? Bad. Okay, so where do we start? P's and Q's? I always want to say peas and carrots. Okay, so plus or minus. Ooh, 24. 8 and 12 and 24. Good gracious. Okay, that's a lot to put on the shelf. Thank goodness we have a what? A calculator. Okay, go graph him. All right, anybody got anything that looks good? What are we thinking? Give me one. -3. Everybody like it -3? All of them? Okay, what do you think all of them are? You'll agree? Okay, let's prove it. Throw me a -3 on the shelf. Watch out for holes. Roll with synthetic. Prove that -3 works. Once you've done that, you've taken a cubic equation and knocked it down to quadratic, so you can either factor it or you can keep rolling with synthetic either way. What do we think? Yeah? Who rolled with synthetic all the way down? Who stopped and factored? Both ways are great. Both ways are great because we just proved those 3. Okay, now let me ask you a question just to make sure that we're super clear. All of these, and 1, 2, 3, and 4, look at the first 4 problems. What is their highest power? A degree 3. So all I have to do is find one solution that works. That'll knock it down to a degree 2, and then don't we know how to solve anything that's quadratic? I can factor it, I can complete the square, and then last resort, I can always do the quadratic formula. So if you knock it down to quadratic, I can handle it from there. Now, when we get down to number 5, he's a degree 4. How many solutions do you have to get with synthetic? 2. Before you knock it down to quadratic, before you can take it from there. Does that make sense? Okay. All right, so try number 3. Try number 3. Okay, so this is what my graph looks like. Is this what your graph looks like? Did I type mine in correctly? Well, he's a degree 3. I thought I should be looking at him crossing the x-axis 3 times. Why is he only crossing it once? What does that mean? I thought he was supposed to have, he's a degree 3, he should have 3 solutions. They are imaginary. Do y'all remember that? I have 3 solutions. One of them is real. I can see it right there. I don't know what he is, but that's him. He's real. And the other 2 are imaginary. He wiggles off in space somewhere. Okay, so now I've got my P's over Q's over there. I need to know what to try. 2, 3, 4, 5, 6. Is 6 an option? Like, is there even a point to putting 6 on the shelf? And I don't even think it crosses at 6. I think it's a little less than 6. Do y'all agree? But do you, like, we haven't really used the P's over Q's yet, but here's where I'm going to use it. Are any of those plausible answers based on my graph? So what does that tell you? It's irrational. Means it's ugly. Means P's and Q's and synthetic division are not going to help me. Plus my other 2 are what? Imaginary. So I have 3 answers. 1 that's super ugly, like probably involving a root, and 2 that are imaginary. So can I get this using synthetic division? Using my P's over Q's? No. He has no rational solutions. I can't produce them. I don't know what they are. There's no way for me to give them to you, for me to find them on my own. Now, you want to give me one of them, I can go find the other 2, because I can divide it in and get the ugly stuff out. I can do that. But this doesn't help me at all. I know that one of them is real, but it's irrational, because it doesn't come from this list. And I know the other 2 are imaginary, because he doesn't cross, they don't cross on the x-axis. They wiggle up in space somewhere. Does that make sense? That relationship is important. Okay, try number 4. Let's see if we have better luck with number 4. Okay, let's see. I got a -5, a -1, and a 4. Which one did y'all get first? Which one did you try? 4, but you didn't get it to work? All right, let's look and see. 1, 4, 6, 24, 5, 20. Huh. Where are your numbers different than mine? So your process is right. You're just, your multiplication is throwing you off. Okay. Are we good? Everybody okay? All right. So we're going to do number 5. And if we're cool with number 5, and just because he's a degree 4, if we're cool with number 5, we'll skip number 6. Because we don't need to do thousands of these. Okay. So for number 5, start with P's and Q's. Okay, then go graph him. But while you're typing, listen and think. How many possibles do you need from your graph for something that's a degree 4? Got to have 2, because you got to knock it down to quadratic. You're going to get all 4, but I have to get at least 2 of them to work with synthetic to knock it down to quadratic. So go graph him. And tell me what he looks like. If I can get my calculator to turn on. Come on. There we go. Okay. 6x squared minus 4x minus 8. What's wrong with that? Oh, I have an extra to the, what the heck? Huh. He's supposed to cross 4 times, right? So does that mean he's got 2 that are imaginary? Oh, you're so headed in the right direction, Matt. That was perfect. -2 should be a solution twice because it stops at it. That's what he said. What was it if it was a, what do we call it if it was a solution twice? A double root. It's called a double root. If it's a double root, what does it do? It doesn't do this. It bounces. Remember, if it's a double root, it bounces like a trampoline, or you hit your head on the ceiling. It bounces. This one doesn't bounce. If you zoom in, you'll look. What is it doing? It's not bouncing, but what's it doing? It sits for a minute, and then it continues on its way. So it's not a single root. It's not a double root. It's a triple root. So single root cuts through, slice. A double root bounces. A triple root sits for a second and then continues on its way. So that means that technically -2, I think, is going to happen 3 times. And then I've got my 1, and those are my 4 solutions. So let's try a -2. And he worked. What am I down to now? I was at degree 4. What am I now? I'm at degree 3, so I don't need to shove x's in here and try to go factor it. He's at degree 3. I'm still helpless. So I'm going to try -2 again. Now, you could try -2 again and then do the 1, but I think it's easier just to go factor. And there they are. Either way, you have to prove them. It doesn't matter which way you go. Okay, here's a what if. We'll skip the last one, but I got to do this what if. Let's say you tried a -2 and you tried a -2 and you got down to this. Okay. Y'all with me? Okay. To put x's in here, what do you got? Is that a factor? No. And you would have no other things to plug in for synthetic either. But I still need the 2 answers that live in him. How do you get those? Could you complete the square? Is this a lovely complete the square? And how do you know? It doesn't have a number in the front. And this number right here is nicely halfable. All right, let's review completing the square. Here we go. So I'm going to have x squared plus 4x. Remember, did I call him Grandpa? Did I do that with y'all? Okay, so 1 is Grandpa. What do you do with Grandpa? Yeah, you move him to the other side of the equation. So he changes signs, right? Because he crossed equals. Okay, what's half of 4? 2, and then you square it. So what do you get? And if I add 4 to this side, what do I do to this side? Yeah, what you do to one side, you do the exact same thing to the other. This is now a perfect square trinomial, which would be x plus 2, x plus 2. So x plus 2 squared equals 3. And then what? Nope. Not squared. It is squared. Square root both sides. Y'all remember that? This sounds painful. Y'all with me? Maybe? This you got to know how to do, man. Equals? Uh-huh. When you root both sides? Plus or minus, thank you. And then minus the 2 and put them in the front. Put the ugly in the back. Circles and parabolas, because your y equals was in the front and everything happened over here. So you just took Grandpa and slid him over, and then what you did here, you did the opposite over there because you're on the same side of the equals. But parabolas are just even to the other side. No, because parabolas are y equals, and then all the stuff is over there. So your equals is way over here. This, you see the equals is down here on this end. Yeah. All right. Evens and odds. Show work to determine if you're even, odd, or neither. How do you tell? Ooh. Do we remember talking about this? Do we remember what you do? Do what? Nope. Because you have to show work. Oh, do you plug it in? Like, you what? Do you what? Substitute. That's hilarious. I can't say plug it in. You substitute. What in for what? And that's my issue with plug it in. Plug it in. Plug what into what? Like, okay. Even and odd. Something about eats it and kicks it out. So if you plug a negative in the x, and then if it eats it, it's even, and if it doesn't, it's odd. Oh my gosh, Jenny, that's awesome. Good job. Right. That's perfect. That's perfect. Okay, so we need to write this down. So if you do f of negative x, that means everywhere there's an x, you shove a negative in it. Not beside it, in it. Okay? If you do that and you get the original function back, and that's when I say it eats it, it's gone, then you're even. If you plug a negative in for all your x's and it changes every single term, so that looks like this. It changes everything about f of x, then it is odd. And then Jenny was right. If it changes some but not others, then it's neither. Okay, so look at number 1. Take a negative and shove it in everywhere you see an x. What's going to happen? It's going to eat it. Because I'm shoving it into an x squared. So the x squared is going to eat it. So when I do this, I get this, which is the original function, which means he's what? He's even, because it ate it. Okay, number 2, plug a negative in there and in there. What's going to happen? Is it going to change one, both? Both of them, because those powers are odd. So this is going to make this, I mean, when I say do it, this is what I'm saying to do. So then that would be negative 4 times negative x to the third, which would be 4x to the third. And that would be a plus 2x. And you can see it changed both of them. So we are odd. Well, it is odd. We are not odd. Except for Ben. Ben's odd. Okay, now what about number 3? First term eats it. Second term changes. And third term stays the same no matter what. So I've got one that eats it, so he stays the same. The middle term's going to change, and the last term's not going to change for anything. So what is he? Neither. Okay. What are you thinking? I heard a nod. Anybody second that? Why are we odd? Yeah, going to change him. And isn't that going to change? So change both terms, so odd. Okay. What about number 5? Throw a negative into the absolute value. This would stay the same. Plug a negative into your x squared. It stays the same. And is anything going to change that 1? So he is even, because nothing changed. Okay, now, how is this guy different? He's got y's. Plug a negative in for both your x and both your y. Plug a negative in for your x, what happens? Eats it. Plug a negative in for your y, changes. So what's the deal? One eats it, one changes. Neither. What about number 7? This is a good problem. If I plug a negative there and a negative there. Okay, you're not ready to make the decision yet. What does the negative exponent mean? I move it, right? So he is going to become that, and he is going to become that, right? Now compare that to the original function. Here's an e to the x, here's my e to the x. Are their signs different? Okay, so it changed. Here's this negative 1 over e to the x. What do I have? I have a positive 1 over e to the x, so he changed. So what are we? They're odd because they both changed. Okay, number 8. What's going to happen to the 3y cubed? He's going to change. What's going to happen to the 4x cubed? He's going to change. What's going to happen to the 1? Not a darn thing's going to happen to that 1. So change, change, and stay the same. What do we got? Neither. Okay, number 9. Change and don't change. So neither. Okay, hold on before you flip. Do you remember symmetry? We had x-axis symmetry, we had y-axis symmetry, and we had origin symmetry. Any function that is odd has origin symmetry. O, O. O for odd, O for origin. So all of these that have origin symmetry, no, that are odd, have origin symmetry. He's origin, and so is he. If you're even, oh, and there's some questions on the test about this. If you're even, then you have y-axis symmetry. And here's how I remember that. Y'all check this out. If I'm even. Is that an even function? If you plug a negative in for that x squared, will it eat it? Okay. Doesn't he look like that? What kind of symmetry does he have? Y-axis symmetry. So if you're even, you have y-axis symmetry. Y'all go with that? Okay. I don't think we don't need to get into x-axis symmetry. Okay. So we're good. All right. Number 9. I'm gonna let you guys chug through this. I want to remind you, if it's quadratic, factor it, set it equal to 0, and solve it. Complete the square. Quadratic formula. Look at number 6. Number 6, I would go big parentheses. What's your common denominator? 6x. Now watch. Multiply 6x squared. X's cancel. 6. 6's cancel. 13x. You see how you can do that to make the fractions go away? Now, he's out of order. Get him back in order and set him equal to 0 and solve him. But that makes it non-fractiony. Okay? When you look at number 5, this is a lobster, right? Who is that? That's a shark. Lobster, then run the shark through very carefully. So just be careful there. Same thing on number 9, I would go big parentheses. How many answers should number 7 have? 4. Okay? So you guys are welcome to work together, but let's do these 9 and then let's check it and we'll see where we are on time. Okay? So do these 9 and then we'll check it. But let's see if we can really do well on it.